Okay, so when we're talking about conic sections, this is your general form of your equation, right? Notice there are 5 parts to it, and each part has a variable or potentially a non-variable if it's the constant. Okay, so we have our x squared term, okay, and we have a y squared term where b is the coefficient of y squared. We have an x term where c is the coefficient, and a y term, and then we have a constant term equals 0. Okay, so this is how we're going to see a lot of our equations written, and you're going to have to tell me, just by looking at them, what type of a conic section it is. Okay, using your eyeballs, and using your brain, and using your amazing analysis abilities. Okay, so if we're going to have a circle, you're going to notice that the ax squared and the by are the same numbers. Okay, if you have the a value, which is your coefficient of x squared, is equal to the b value, which is the coefficient of y squared, you're going to have yourself a circle. Okay, and the standard form of a circle looks like this. So from this standard form of our equation, we can know directly that the center of our circle is at the point h comma k. Okay, it's the x coordinate comes from the x parentheses, and the y coordinate comes from the y parentheses. Imagine that. And the radius is the square root of whatever number this happens to be. Okay, so we're going to take our general equation and write it in standard form so we can answer questions about the attributes. And in this case, the center and the radius are the attributes for your circle. Okay, our parabola. What is unique about a parabola is that it only has one squared variable. Okay, parabolas only have one squared variable, either an x squared or a y squared. Okay, x squareds open up and down, and y squares open right or left. Okay, so there's going to be a general or a standard form for that also. So here's our standard form. So if we have a parabola that opens vertically along the y-axis, then the x is the squared variable, like y equals x squared. Think about that one that opens vertically. Okay, or if we have a y squared that opens horizontally, so it either opens to the right if it's a positive, or opens to the left if it's a negative. Okay, so we can tell that our section is a parabola because only one variable is squared. Okay, ellipses. You can notice that something is an ellipse if you have an a value not equal to a b value. Okay, your x squared coefficient is not equal to your y squared coefficient. If they are different, then you have yourself an ellipse. Okay, and this is what the standard form of an ellipse looks like. So here's our ellipse. We still have that circle-looking thing where we have a parenthesis thing squared, and h is the x coordinate of the center. But then we have this divisor by number, okay? And this is going to be how far you go to the left or to the right. You're going to go a units from the center to find the major axis or the minor axis, but we'll talk about that later. Okay, so you take the square root of the bottom number to get that value, though. Okay, we have a plus in the middle. There's always a plus, and then here's the y part, and then it equals 1. So unlike a circle, right, ellipses always equal 1 in their standard form. Okay, so we have different values of a and b, and they equal 1 in their standard form. So lastly, the hyperbola. The hyperbola is different because it has an x squared minus a y squared. Okay, you notice it's a hyperbola because there's a minus in between your squared terms. So it could either be x squared minus y squared, or it can be y squared minus x squared. And the equation looks very similar to an ellipse. So either one of these two equations is how we're going to see our hyperbola. But the most important part is your minus. Okay, so if it's a x squared is positive, then it's going to open left or right along the x-axis will be your positive axis. And if the y squared is positive, it's going to open up and down along your y-axis if the y part is positive. Okay, so let's take a moment and see if we can answer some questions about which type of a conic section we have. So here we have 9 general form conic equations. So we're looking at x squared and y squared, and what do you notice? That 3 and 4 are different, so this one is an ellipse. Okay, moving to the right, we have a minus, and if there's ever a minus, this is always going to be a hyperbola, no matter what is going on with those other ones. Okay, our next one, we have a 4x squared and a 4y squared. Notice they are the same, so this is going to be a circle equation because your a and your b are the same. Moving down and over, I only see a y squared. So if I only have 1 squared, I know that it is a parabola. Okay, this one, notice they have the same variables, but it's a minus. And anytime there's a minus, we have a hyperbola. I only see 1 squared variable. There are a lot of 5s there, but the squared variable means that's a parabola. This one has different coefficients, so it's an ellipse again. This one has the same coefficients, so it's a circle. And this one has a minus, so it has to be a hyperbola. Hyperbola. Okay, so those are the things that we're looking for when we're trying to identify what type of a conic section it happens to be. Okay, lastly, let's take a couple minutes to sketch some of these. So I have ellipses and circles. So here I have a circle, and looking at your equation, right, this is in standard form. So we have an x value of 2 for the center and a y value of 5. So we have the center of our circle at 2, 5. Okay, because parentheses always lie. So when -2 in parentheses leads to a +2 coordinate. And because I have a 16 here, remember that's radius squared is 16. The radius of my circle is the square root of 16, which is 4 units. So to sketch, I'm going to go 2 units to the right and 5 units up. And I'm going to put a dot that represents the center of my circle. Now from that dot, I'm going to do my best to go 4 units equally down, 4 units equally to the right, 4 units equally to the left, and 4 equal units up. Okay, now this is the hard part to do by hand, is to actually sketch this so it looks like a circle. So let's see how I do. Missed that point, got that point. There, not too shabby, kind of looks like a potato, but it has everything that we need, right? The radius is 4, and it has the center at the right point. Okay, so don't be sad if your circle looks more like an amoeba than it does a circle. Okay, with practice and a steady hand, you might be able to graph better circles in the future, but it takes practice. So looking at our other example for our circle, notice there's no parentheses with the x. So that means you're going to have a center at 0 in the x and -3 in the y. And our radius is the square root of 9, which is going to be +3 units. So you go 3 units down on your y-axis and you put your dot that represents the center. And then you do your best to count 3 units equally in every direction. Okay, the more equally that you do this, the more circular your circle will end up looking. Okay, if you have grid paper, then more power to you. But if you have unlined paper, just do your best. Okay, let's check some ellipses. So here we have a different form for our ellipse, but kind of the same information. We have an x coordinate of +1 from your parentheses and a y coordinate of -2. So we're still finding the center of your ellipse at 1, -2. But we don't really have a radius, right? Ellipses are not equal all over the place. So let's go and make this 1 left and 2 down. Sorry, 2 down. There's your center. 1 left and 2 down. Now notice there's a 16 beneath the x. So this is going to tell us that we're going to go right 4 units to the left and 4 units to the right, because that's what the square root of 16 is. So you do your best to count 4 equal units to the left and 4 equal units to the right, as equal as you possibly can if you are freehanding it. And then notice underneath the y is a 4. So this is going to tell us how far we go in the y direction, and the square root of 4 is 2. So you're going to go 2 units up in the y direction and 2 units down. Right? And these are your major and your minor axes. Okay, so then you do your best to make it as elliptical looking as possible. Okay, making sure your curves are as nice and curvy as you can. Okay, so if we were asked the question, what is the major axis? Okay, the major axis is 8 units long, because that's the distance from the far left endpoint to the far right endpoint. So we would have a major axis length of 8 units. And we would have a minor axis length. Okay, minor is your smaller one, of 4 units. Okay, and then the last thing they might ask you about is your focus. And since there are 2 of them, they call them the foci. The foci. Now the foci are very special little points. And you find the foci by doing some Pythagoras. It is the square root of a squared minus b squared in absolute value. Okay, always an absolute value, because maybe one's going to be bigger than the other or whatever. Okay, so we do the 16 minus 4, which is 12. So the square root of 12 is approximately 3.5-ish. So we would go from our center 3.5 units to the right and put one of your foci, and you would go 3.5 units to the left and put your other focus. I guess these are individually called a focus, but together they are foci. Okay, so that would complete your entire graph of your ellipse. Okay, so one last example over here. We have x plus 3 squared over 9, and plus that one equals 1. So let's pause the video, and you can go ahead and sketch that. I'll be right back with all the info. Okay, so that's all of the information about this ellipse. Okay, center at minus 3, 4, major axis length, which is 10 along your y direction, a minor axis, which is 6 in your x direction, and your foci always go along your major axis. So we're 4 units above, and we're 4 units below the center for this particular ellipse. Okay, so hopefully that clears up some things about conic sections, especially circles and ellipses, and you're able to find their attributes as well as sketch them.